Hello everyone, welcome to this tutorial on data structures.
In this tutorial, we will be discussing the following problem definition. The problem definition goes like: accept an alphanumerical string that ends with some special character and push the contents on the three separate lists, that is letters on one list, digits on the second list, and a special characters on the third one. Now, let's see some few approaches available to this given program, that is array, linked list, queues, and stacks. See the logic behind the implementation of stacks using arrays. First, take sample input string. Now, maintain three stacks. Now, we scan through the list. The first variable encountered is A. Being an alphabet, it will push into the alphabet array. Now, secondly, 7 being a number, it will push into the digit array. Similarly, all the inputs will be pushed in the following corresponding arrays. And lastly, a caret symbol being a special character will be pushed in the.
Now let us look at the implementation of the given problem definition with the help of stack using arrays. Firstly, we include three header files. The ctype.h header file contains functions such as isAlpha, isDigit, isAlphanum, etc., which are used for testing and mapping characters. Secondly, we define a constant max to be 100. Now, we declare 4 character arrays, one for letters, one for digit, one for special characters, and the last one for reading inputs from the console screen. Now, we define the top pointers of the three stacks to be -1. Now let us look at the push function, which takes character C as a parameter. The encountered character is checked using two if condition. The first if condition is used to check whether the encountered character is an alphabet. If the condition is true, then the top pointer of the alphabet stack is incremented and the character is pushed into the respective stack. The same goes for numbers. Now, if both the if conditions are false, it means that the encountered characters was a special character. Hence, the top pointer of the special character stack is incremented and the corresponding character is moved into the special character stack. Now going towards the display function, which takes two parameters, namely a character array and its corresponding top pointer. As we know that stacks follow last in first out rule, therefore the for loop traverses the stack array from the top pointer to the 0th element of the array and then prints the corresponding elements. Now going towards the driver function, that is the main function. Firstly, we take an alphanumeric string as input from the user. Here we have defined a while loop which traverses the entire input string until it encounters the special characters. Until then, all the characters are pushed into their respective stack. Lastly, all the three stacks are displayed. Now let us check the code. For the first test case, let's take input as say CVB 45 and a special character asterisk. As we see, the letters BBC, digits 54 and special characters asterisk are separated into their respective stacks. Let's run the code again. This time let's take a different test case. Say ZMN76, a special character, say $, and again digits 2 and 3. Now we see that the letters M and Z, digits 6, 7 and special character $, are being segregated appropriately. However, the digits 3 and 2 which occur after the special character are not being taken. Thus, we see that our code runs properly.
This method of stack using arrays is not viable. As arrays are not dynamic in nature, it leads to memory wastage or memory shortage. In this tutorial, we've implemented stack using linked list. The advantage of this approach will become evident in the further part of the tutorial. Let us understand the algorithm. The first step of the algorithm is to read the input string from the user until a special character is encountered. The second step is to maintain three separate stacks. It's one for alphabets, one for numbers, and the last one for the special character. The third step is to segregate the characters in their respective stacks, that is digits into the digit stack, alphabets in the alphabet stack, and the special character in the special character stack. And the fourth step, that is the final step, is to print the respective stacks. Now let us understand the stack ADT. Following is a visualization of how stack works. So let us understand how stack works. Let us understand the push operation first. So let's push some elements. Let's say 40. Next, let us push 80. Next, let's push 100. And then finally, let us push 120. Now, since stack follows last in first out rule, the first element to be popped out will be the element which was entered last. That is, in this case, if we pop the element, the popped value will be 120. Now 100 is at the top of the stack. When we pop the next element, 100 will be popped out. And similarly, the remaining elements are popped out of the stack.
And the logic behind solving this problem. The first step is to read the input string. Now here we have the sample string. The next step is to maintain 3 different stacks for alphabets, digits and special characters. Now let us segregate the input string. We can see that A being an alphabet is pushed into the alphabet stack. 7 being a number is pushed into the number stack. We can see that the rest of the inputs are pushed into the respective stacks. Lastly, we can see that hash being a special character is pushed into the special character stack.
Now, let us look at the implementation of stack using linked list. Firstly, we include all the necessary header files required to build our program. That is stdio header file, malloc header file which includes the malloc function, and ctap header file which includes isDigit and isAlpha function. Now we define a structure to implement stack which has an integer data field and a self-referential data type pointer which points to the next location. Now we define 5 pointers of type stack, namely top, top 1, top 2, top 3 and start. Let us see the push function which takes 2 parameters. One is the top of the stack and another is the data element to be pushed. Now allocate the memory to new node using the malloc function. Insert the value to be pushed into the data part of new node. If the stack is empty, then we make the new node as the first node and make the next part of the new node as null. If the stack already contains some elements, then we push the new node to the top of the stack and make top to point to new node. Return the top as the return type.
Now coming to the display function. In the display function, a pointer is maintained and assigned the value of top. If top is null, that is, if linked list is empty, then the value 0 is returned. Else, using the while loop and pointer, the linked list is traversed. If the encountered character is a digit, then it is printed in the form of an integer. Else, it is printed in the form of a character. The pointer variable is updated in each loop of the while. Hence, in this manner, the display function prints the entire stack. Finally, let's have a look at the main function. Define a character C which will be used to accept the characters of the string. Initialize an integer I to 0. Now, using the while loop, we will take input from the user until a special character is encountered. The function isAlpha is used to check if the character is an alphabet, and the function isDigit is used to check if the character is a digit. This process continues until a special character is encountered. Until then, the characters are pushed onto their respective stacks. When a special character has encountered, it is pushed onto the third stack and the control breaks out of the loop. When this happens, the 3 stacks are then finally printed. Now, let's test the code. For the first test case, we take an arbitrary string ABC123 and end it with the asterisk. As you can see, the string has been divided into letters, digits and special characters. Now for the second test case, let's take the following string. As you can see, while the asterisk has been encountered, the program stops taking any further inputs, which is why the digits have not been encountered. This shows that our program successfully works.
Implementing the stacks using linked list. Stack is a dynamic data structure, so it can grow and shrink at runtime. Insertion and deletion of the nodes are really easier. Unlike arrays, here we don't have to shift the elements after insertion or deletion of an element. As the size of stack can increase or decrease at runtime, so there is no memory wastage. Also, overflow is not possible unless the system memory is exhausted. Thus, we have successfully implemented the given problem definition with the help of stacks using linked list. Thank you for watching.